Imagine a busy CNC machining facility. Automated equipment runs at full speed, spindles hum, and the pressure to hit daily production targets is relentless. You're operating a machine when you notice something subtle. The pitch changes slightly. The machine vibrates. The surface finish looks different. You glance at your production counter. The target is 500 parts and climbing. You know that stopping the machine means halting the entire process. In that fraction of a second, you face a choice. Do you hit the stop button or let it run to finish the batch? That decision separates a 5-minute equipment check from a catastrophic financial loss. Let's see what happens when the operator pushes through and ignores the vibration. The machine keeps running and the production quota keeps climbing, but that vibration ruins dimensional accuracy. One flawed part quickly multiplies into 50. This flowchart shows the nightmare. Components fail inspection, turning a quick fix into a massive sorting operation, manual rework, and expensive scrap. The massive expense here didn't come from a complex mechanical breakdown. The delay and the cost happened purely because a known problem was allowed to continue running. Let's rewind the timeline back to that strange sound. In lean manufacturing, there's a simple protocol designed specifically to prevent this crisis. Stop, call, wait. The first step is immediate. If you detect a genuine abnormality, whether it's tool wear, a missing component, or a safety hazard, you stop the process. You do not wait to see if it gets worse. This requires a shift in priorities on the factory floor. The primary metric of a successful shift is not producing a high volume of parts. The metric is producing good parts. Hitting the stop button is never viewed as an operator failure. It is a necessary defensive action to protect the business and keep defective work from reaching the customer. By stopping the machine immediately, you essentially quarantine the physical abnormality at the source before it has the chance to infect the next step in the process. Once the process is halted, you move to the second step, call. The operator triggers an alert system to immediately notify the right support network, usually a team leader, quality control, or maintenance technician. Look at this overhead Andon board in a real Toyota facility. When an operator signals an issue, the board lights up, instantly creating situational awareness so the entire floor knows exactly where help is needed. This highly visible communication eliminates dangerous habits. You don't silently restart a machine. You don't hide defects out of fear, and you never assume someone downstream will catch the error. The purpose of the call step is to lift the burden of problem-solving off the isolated operator. It brings leadership directly to the gemba, the actual place of work, so they can assess the facts firsthand. That brings us to the final and often most difficult step, wait. It takes discipline for an operator to stand by a quiet machine and resist the urge to restart it while production targets slip further away. But the line must be held. While the machine is stopped, the support team arrives. They physically inspect the cutting tools, measure the fresh components, and perform a rigorous root cause analysis on the equipment. This diagram outlines the strict criteria that must be met before normal production can resume. The problem must be identified, the root cause understood, the mechanical correction completed, and a new verification part must be checked and approved. If you skip these checks and turn the machine back on without decisively identifying and fixing the true cause, you guarantee the exact same failure will happen again. This chart compares the actual business impact of those decisions, using an illustrative example of a machine producing 100 parts per hour. If you stop early, you contain the damage. Only one single part needs to be checked or scrapped. If that same machine runs for 2 hours without intervention, you are looking at 200 affected components piling up. Early detection limits the size of the problem. This whole framework is the practical application of Jidoka, a central philosophy in lean manufacturing. Jidoka dictates a simple rule: an abnormality must never be allowed to pass to the next step. But for stop, call, wait to actually work, a facility needs a blame-free culture. If an operator reports a defect, the operational system takes the blame, not the person. Workers must feel psychologically safe enough to pull the cord, because a problem that is visible to the team is a problem that can be solved. A problem that stays hidden will inevitably mutate into a massive liability. Stop, call, wait. Never pass a problem to the next process. If you enjoy simple, practical manufacturing concepts, subscribe to Learn and Grow with Fun. Learn, grow, and have fun while doing it.